When we put flash into 3PAR, it goes straight off the charts from there as well. And we'll talk about flash and what 3PAR config can give you. And then the idea again that you can scale out, you can wire them together, you can take 4 7200s and make them all look like a logical array. Very, very cool. So to sort of capture that, these have been the traditional 3PAR bread and butter onto the right-hand side, what we call our 10,000 series. Quite simply, all we're doing is saying, well, not everybody in the room here has a petabyte of data they need to use, but I really like those features. Can I have it in a small 2U rack? And that's a 7200 starting at about 30K. And that's the new market for us. Normally in our portfolio, what we call the P2000 or the MSA or even the EVA product fits in that sort of mark. But EVA and P2000s were great architectures before the proliferation of VMware. They can run a VM. Lots of our customers, we've got 2,000 EVA customers in Australia. Probably 80% of them run with virtual machine environments. But when you get to the point where you know that performance needs to go up, when you know that you're doing big sequential workloads like backups or data analytics, and you get your CPU saturated on your controller because you've only got 2 of them in an EVA, and you can scale up dramatically more with 3PAR, that architecture, that stuff I just mentioned, matters a lot. It's scaling up by a factor of 10x over a 63 or 6500 EVA. Okay? So scalability, the actual way the guts of a 3PAR are wired together matters a lot. And so, one architecture all the way through, you can start with a small little 7200 and effectively then have a 10,400, with 900 spinning disks, or have a 10,800. And a 10,800, we've actually got a working model, and you can buy a config of that with 512 SLC SSDs running at 20,000 IOPS each. That's the sort of scale you get to. Same architecture. Okay? This thing here has 192 fibre channel ports in the back of it. Again, same architecture. So what that actually means is with this one, just to show you the scale, you can run 48 blade system HPs fully decked with 24,000 VMs on a single storage array. Okay? So that's the kind of scale you get. And I'll also make the point is that you don't need any SAN fabric to do that. They just plug directly into a blade system using Virtual Connect technology. So that's the sort of scale you get. Again, same architecture, same look and feel. The point there is, investment protection all the way through. So we talk about Tier 1 storage, enterprise class storage now at, in that sort of 30 to 40K starting point. And that's sort of the difference with us. So let's talk about some of the benefits here and where our customers see the smarts, what we call these autonomic capabilities. And the biggest one is probably, and that's why cloud providers love us, because you just want to click on a button and provision storage. You don't want to have to work out, well, which stripe and which chassis and where do I lay out the data, and it does it all for you. Same as in VMware, where in most cases you don't care which CPU or which DIMM in which slot you're actually storing your data. That sounds a bit nuts, right? But in storage, traditionally, you've got to know exactly which spindle on which chassis and stripe it across and do all that yourself. 3PAR does that for you. And it does it very, very fast. And if you change your mind, you just click a few mouse clicks and then bang, it will re-tier the data or redo whatever it needs to do. The other idea is as well that, in storage, things break. It's an electromechanical device. So resilience needs to be built in. And you need to have resilience so that if you have multiple controllers in your architecture, that if one of them fails or you have a firmware upgrade or you want to add more capacity, then you don't have to bring the whole thing to a shuddering halt. So it's built for what we used to use this term, carrier grade service delivery. So that's kind of built in. 3PAR is kind of a benchmark standard there. I had a customer in Queensland the other week, and they had a serious issue on one of their controllers. They had a hardware outage. And they upgraded, they've got what we call a T800, so an 8-controller 3PAR, which is like the 10,800. They upgraded completely non-disruptively to the business, all 8 controllers. No outage, no loss of service. Now do that in an EVA or a Clarion or whatever else, you just can't do it. You've got to have an outage. So that's the major thing. And again, what you get with the 4-controller model on 3PAR that we'll talk about, why that matters. And then, adapt to the unpredictable. One thing a 3PAR does, when you add more disk onto 3PAR, it will then, with a click of a button, restripe across all of those new spindles. So you get a fairly linear upgrade in performance. Most storage architectures, when you get to about 120 disks or so, actually get slower the more disks that you add. So you can have 1,000 disks, but it's actually not running at optimal speed because your CPU is already maxed out. what we do in 3PAR, we actually warrant the performance to certain levels. So you know predictably that if you add X number of additional disks, exactly where your performance will be and what that will mean in milliseconds to your host. Okay, so it's very predictable performance, even when you start thrashing it with all sorts of random I/O workloads. 3PAR is built for random I/O. That's part of the multi-tenancy side of things. I asked Charlie, I thought, so who's our audience today? And Charlie assured me that some of you would love this chart, so sorry if it's a little bit technical for some of you, but this is a traditional monolithic array, or like a mainframe class array. You know, how they get performance is what we do in our XP class, or our 9500, which we ran from Hitachi. Normally you've got lots of ports, you've got tons of cache, costs lots of money, and you have lots of what we call disk directors, or ways to path the traffic with some custom silicon. But traditionally, if you have, in this case, an 8 gig LUN, even with all of this muscle, okay, you're still just striping the data to a couple of spindles. Now, spindles in storage, as you all know, mean a lot. That's the horsepower, the engine for what drives the I/O and how the writes and the reads actually happen. But for me to actually spread that across, this is RAID 1 across multiple shelves for resilience. I'm only getting the I/O from a very, very small number of spindles. In a 3PAR concept, because all of these disks are virtualized, just like memory or CPUs virtualized in a virtual machine, my LUN spreads into these virtual little disks, we call chunklets in 3PAR, and writes across 64 disks. So just on that, you've got the I/O of 64 versus 8. Okay? Fundamentally different way. There I have to manually lay it out. Here it's all done for you. Okay, you want to move it? It will do it itself. You add another bunch of disks, it will then restripe that across the whole bunch of new ones and give even more performance. Okay, you don't have to think about spindles and layouts or pools or reservations ever again. Major difference. That's sort of clear for everybody? Cool. The other thing here is that this is a 4-controller array. So the idea in 3PAR is that in a quad controller model, this is a 7200 or just a normal 2-controller, that if one of those nodes fails, I get cache persistence. So normally in a lot of arrays, you're going to write through mode, you've got to down tools and bring the array back up. Or even with some of the new arrays, these new so-called SSD hybrid arrays, they have an active-passive thing where the disks are actually wired into only one controller. 3PAR, all the controllers work as sort of like one big super mesh active controller. Okay, it's like a parallel multi-scalar design. Gives us great performance. So again, the efficiency comes, I think we spoke about, actually, if you've got 100 terabytes, 3PAR will show you how much you can save, and that's part of the assessment that CSW want to run with you. So normally we see 50% less. On some LUNs, like VM LUNs, we've seen an 80 gig LUN go down to less than 20 gigabytes of actual data when you migrate across the 3PAR. So you save 60 gigabytes. That's the maths of it. But then you've also got the way that 3PAR tiers. Now again, tiering is a kind of an interesting concept with a lot of arrays. Tiering for us means that you can have it happening automatically by itself. So if you don't know and you're just kind of guessing what the performance is, you can put it in the tier. 3PAR will work out the correct tier for you. But the other thing as well is that you can save a ton of money by not having to make databases RAID 1 or RAID 10 if you're striping across lots. Because 3PAR's performance for RAID 5 or RAID 50, if it's striping, is 90% of what most people need RAID 10 for. And the way we do that is in hardware, because we accelerate the way that RAID works. So you can get the best tiering based on dollar per gig and dollar per I/O, two important metrics in storage. Because I get really low dollar per I/O with SSD, I/O per SSD, but my dollar per gig is massive. So getting the right benefit of that is the tricky bit to do. 3PAR takes care of that for you. And the net thing is that you need dramatically less floor space because the density, and you can see the density of the array here, but because you need more at high utilisation, need less spindles at high utilisation, means that you need dramatically less on the floor tiles. So real estate, power cooling, not to mention admin and efficiency and all the rest of it. And I just want to touch on a little bit with the thin technologies here because, thin provisioning with us, the key thing here is that it's not tricky. It's kind of native to the way that the array works. And the whole idea normally is with most thin provisioning implementations is that people aren't confident using thin because they think, what happens if I run out? Okay, so you need the management, the reporting, the alerting, which is all built in. But the other thing is as well that you don't need to pre-reserve which disks are going to be thin disks like you do in a normal array. The whole thing can be thin because every disk is virtualized. Okay, so over here, it'll just stripe across the whole lot. It doesn't care. Okay? So a big difference in the way that you can use thin provisioning with a huge amount of confidence. And the idea is as well that you can have different quality of service for different types of thin pools. It's all policy driven. You can say, well, these thin pools, that's a fast one, that one's a slow one, that one's for dev and test, and take snapshots on different tiers of disk. It's very, very flexible. Again, the reason we get that is because it's all policy based, the array's all virtualized. So a LUN becomes a virtual concept in a 3PAR. What you do with it, thin, fat, fast, slow, you can mix and match how you need to. When we do a thin conversion, I've got a little picture of it there, that's the ASIC, the little chip that we have in every one of the control units. And again, the ASIC, you've got 2 of those in the 7200 over there. Don't know, we could maybe pull it out, Kelvin, and have a look. It's exciting stuff. But the idea is that when you do a conversion from the old storage array to the new storage array, what this little ASIC is doing is in the path of data to actually strip out those zeros. Okay? Strip the zeros from the old line to the new line in flight, in those little 16K units. Okay, so a very fine-grained way that we detect wasted capacity and then write data. And then the idea is as well that thin persistence means that when you, for example, have Oracle or SQL Server or with VMware, and you want to delete capacity and then reclaim it, again, all of that's automated. Now that's not such a big deal now, the way VMware does it in vSphere 5 or the new patched version, because they had some issues with that. The difference is that the performance, because we offload the processing of that zero detection, means that the array is not bogged down trying to do reclamation. Now, a big point usually here, someone says, yeah, but is that like deduplication? And it is like deduplication. It deduplicates the zeros, the wasted space. Because putting in something that filters all data and then has to rehydrate, dehydrate data as it goes in and out of the array, slow things down. This thin and the way that we do this efficiency has no performance tax. Big difference in traditional dedupe. We absolutely believe for dedupe for data at rest, but for production in-flight data, for say a VMware farm, where you need high I/O, not so proven yet. We can show that. So again, the idea is that we talk about using half the storage. We have the Ninja tool, I think, as the method that we showed. And the Ninja tool is for example, if you're an EVA customer, we can take the stats straight out of your EVA and then migrate data using this tool and assess for you to show you how much you would save. Very simple tool, very easy to do. And then we can also show what an EVA looks like and then how 3PAR would actually look. And that's the assessment that we do. So in terms of this multi-tenancy, I think we touched on this. The idea is that you can have lots of different workloads consolidated on an array. You don't need to buy arrays fit for purpose. 3PAR can balance them. And then when you have failure, like a node falling out or you have a disk tray that dies, 3PAR is built to have multiple failure points at controller and also in disk. So it's designed for you to fail. Now 3PAR is also doing its real-time monitoring to HP, so that, for example, if you have just one disk that starts to go a little bit dodgy, 3PAR will say, sorry, I'm going to mark the disk as bad, move the data to the next drive. You don't have to worry about any of that stuff. It just happens for you in the way that it balances. If you're writing too much data, for example, to the wrong tier, we'll also give you like policy advice to say that you're writing too much data to a non-performance tier of storage, perhaps you'd like to look at moving an upper tier. That's the sort of stuff that 3PAR also does to make sure it works. Now, I thought I'd just put it in. This you can see the thing in the flesh here. This is a 7000 series benchmark on SSD. And a new feature that we're coming out with, and I thought I'd sort of road test this because this is still in beta and it's something a lot of the cloud providers use, but a lot of customers are saying they'd like it too. You can see over on the left-hand side, you can have, in this case this is 7400, fill it with 240 SSDs, only SSDs. Love to sell you one of those. We kind of contend that you don't need SSDs unless you have a special sort of problem. But, whoever in the room here needs 320,000 IOPS in a single array I'd like to meet, because it's probably less than 5% of customers in Australia at the moment. But that said, SSD is fun, speeds and feeds are always there. What we kind of say is that you get a huge performance kicker with 3PAR, just the way that you stripe across all of those SSDs. Okay? That's the kind of difference with us. If you just buy SSDs in some other arrays,